All right, this one's going to be short and sweet, guys. We got one side of one page. Today we are solving one-step equations. And something I always say to my students is that in math, we are not creative. When it comes to naming things, we tell it like it is. And so when I say we're solving a one-step equation, that means that one step is going to be between you and your solution. So let's get started. A solution. What the heck are we talking about when we say a solution? A solution of an equation is the value or values, if you have more than one, that make the equation true. So what do I mean by true? Well, a true statement is when you plug something in and you evaluate and you get something like 12 equals 12. That's a true statement. A false statement, so if I plug something in and it doesn't work, that would be like if I had -3 equals 2. And that's not true, right? So that would mean that whatever I plugged in does not work. It is not a solution to my equation. Well, how do we go about solving operations? Well, it's like reverse engineering something. Have you ever like taken apart a pen and try to put it back together to see how it works, right? To get back to what was happening to get the answer to the equation, we use inverse operations. They undo one another, okay? And we use them to isolate the variable in order to find the solution. And isolate is just a fancy way of saying get by itself. So we want to know, an equation is like I have some number and I do something to it, right? I add or subtract or multiply or divide or some combination and I get out a new value. Well, how do I work backwards to figure out what we started with? All right, so let's list some inverse operations. I bet you already know a bunch, and throughout algebra, you're gonna learn even more operations that you didn't know existed. But for now, let's go ahead and list ones you do know. All right, were you able to list some for me? All right, so examples are addition and subtraction, multiplication and division, and squaring and square rooting. All right, so let's do these in action. So let's solve the following equation. X minus 5 equals 8. Now, with these one-step equations, you might be able to just solve it in your head, right? The reason we're using inverse operations to solve these equations is not because that's the most efficient way to do it, but it is to lay the foundation for solving more complex equations in the future. If we're always doing kind of guess and check or figuring it out in our head at this stage in the game, we're going to start solving equations in the future that are more and more complex to the point where we won't be able to do that anymore and we'll have to rely on these inverse operations. So if you feel like, oh, my teacher's being so annoying, like I could have figured out that was 13, spoiler alert, just by thinking about it, I didn't have to solve the equation. Well, you're probably right. But it's about getting those skills ready and sharp for when we have to rely on them. So if you're in any sort of um, like extracurriculars or like a fine art or a sport, there's probably fundamentals that you think are kind of ridiculous, right? But you keep practicing them because without those, you can't do the things that you want to do in the future. All right, I'll get off my solving equation soapbox here. All right, so let's think. I have x and I'm subtracting 5. So what we're going to do is I am going to undo that by adding 5 to both sides. Now, when I do that, the reason it works is because, right, -5 plus 5, that is a 0 pair. It's going to get out 0. And so those will go away, right? I saw someone recently like Z those out as a like Z for 0. Anywho, we're going to end up with X is equal to 13. Now, how do we know that our answer is correct? Well, to check your work, so this is what I was talking about earlier with true statements. So to check your work, plug your solution into X in the original equation. So this would look like the following. So I would write, instead of X, you leave a space, minus 5X. Wrong color. All right, so we have something, minus 5, and I'm going to put this question mark over the equal sign because we don't know yet if it works. So I'm going to take my solution here, which was 13. And I have 13 minus 5, and I want to know, is that 8? Well, let's do 13 minus 5. Yep, that's 8. 8 equals 8 is true, and so that's how I know that my solution is correct. Because I got out that true statement. If I had gotten out like 45 equals 9, then we would know we made a mistake somewhere. And we could go back and look for that. All right, next one. We have X plus 4 equals 10. So if I want to get rid of adding 4, I'll subtract 4 from both sides. And I'll end up with X is equal to 6. And so again, if I want to check my work, we have to think to ourselves, 6 plus 4, is that going to get me out 10? Sure is. All right, next we have 3x. So what's going on here, right, is multiplication. 3 and x are being multiplied together. So how I am going to undo that is I'm going to divide by 3. But if I divide by 3 on the left side, right, I have to divide by 3 on the right-hand side as well. And so here, these cancel, not because we get a 0 pair, but because they become 1, right? Because that is the multiplicative identity. But that's doing too much. Anyways, we've got x is equal to 4 here. And so again, if I want to check my work, it works a lot the same, where I'm going to rewrite the equation, but instead of the original equation, but instead of putting in x, I'm going to put in 4. And lo and behold, 3 times 4 is 12. So that one worked out as well. All right, go ahead and try this division one here and let me know what happens. All right, so I'm going to rewrite the problem just so you can see what I'm doing here. I'm dividing by 5, and the inverse operation of that is going to be multiplying by 5, but I'll have to multiply by 5 over here as well. So those will cancel, and I'll get x is equal to 15. And then, of course, we're going to check our work. So we'll set up the equation here. And if I plug in 15 and I divide it by 5, is that 3? Sure is. All right, and there you have it, guys. We solved some one-step equations.